So in this video, we want to apply the power rule in a case where we have functions that have or are in radical form. So for the first example, it says find the derivative of f of x equals the fourth root of x cubed. And when we look at this, we want to recognize that it isn't in the form x to the a. We don't have the form x to the a that we need in order to apply the general power rule. So what we want to do is manipulate this so that it is in the correct form. And what we want to remember is that taking the fourth root is the same as raising x cubed to the 1/4 power, which is the same as x to the 3/4 power. And now I do have something in the form x to the a, with a equal to 3/4. So now I can apply the power rule. The power rule says that if I want the derivative f prime of x, if I want the derivative of f of x, I just need to take d dx of my function x to the a. And to take that derivative, I bring the exponent down into the coefficient position on the x, and I decrease the exponent by 1, which is going to give me 3/4 x. 3/4 minus 1 is just negative 1/4. So for a second example here, we want to find the derivative g of t. So we need to get a function that has the form t to the a in order to apply the general power rule. I don't have that form yet, so I want to take my g of t. It's 1 over the cube root of t squared. So we want to recognize that to take the cube root of t squared, we're really just taking t squared. 1 over, we're really taking the t squared and raising it to the 1/3 power. 1/3 power is the same as the cube root, but this is just 1 over 2 times 1/3 is 2/3. 1 over t to the 2/3. I still don't have the form t to the a. I am 1 over t to something, so I need to get, that's a horrible exponent, t to the 2/3. It's still terrible. So what I'm going to do to get it in the form t to the a is I'm going to bring the t up into the numerator position. So I get 1 times t is t to the negative 2/3. And now it has the form t to the a, with a equal to negative 2/3. So now I can apply the general power rule, which says to find the derivative g prime of t, I just need to take d dt of t to the negative 2/3, which means bring the exponent down into the front position, or the coefficient position on the t, and then subtract 1 from negative 2/3, so we get negative 2/3 minus 1. So we're just going to get g prime of t equaling negative 2/3. T to the negative 2/3 minus 1 is negative 5/3 for our exponent.